again, you are welcome to my YouTube channel. Still on nuclear chemistry. In this particular video, I'll be explaining the radioactive decay. We have a lot of emission in nuclear chemistry. We have the alpha emission, beta emission, then gamma. These are the three major ones. I'm going to explain the other ones later. So, but for now, the first one I have here is alpha, beta, and then the last one is what? Is gamma. So let's talk about the differences so you can understand better what alpha looks like, what beta looks like, and then what gamma looks like. Please take note. For alpha, it has the nucleus of a helium, which is, it talks about the nucleus of the helium. Remember, the nucleus of the helium, like what I said in my other videos, the nucleus already contains or consists of the proton and the neutron. That means 2 proton, there are 2 neutron. So here will be 4, here will be 2. So if you have a question, if you see any question like this, which of the following radioactive emission has a nucleus of helium or has 2 proton and 2 neutron? The answer is what? Is alpha decay or alpha emission or alpha particle. Anywhere you want to put it. So please take note of this. Then as for the beta, it talks about the electron. And you already know electron is usually like this, -1, or it can also be like this, +1. So in this kind of radioactive decay, it can be positive, it can as well be negative. That means it actually reduces by 1 proton or increases by a proton, by 1 proton. So if it's negative, you always call it as beta emission. Then if it is positive, it is no longer beta emission, we call it a positron. So it's either it's a negatron or a positron, but both of them, they are usually what? Beta emission. So beta, it can be written like a beta plus, or let's put the plus at the front, or a beta minus. So for a beta plus, it is called a positron, while a beta negative is called what? A negatron. But please take note of them. Both of them, they are talking about what? Beta particle. While for the alpha, usually have this symbol. So if you see something like this, is also talking about alpha emission. If you see something like this, also talking about what? Alpha emission. While gamma, it has an electromagnetic wave. Gamma is usually a wave, and the kind of wave you have is electromagnetic, and this is the symbol for gamma. It shows no deflection compared to these other two. Then the other thing is talking about the charge. The charge of alpha is usually +2, beta is usually -2, then for gamma it is what? 0. What about the relative mass of alpha? The relative mass of alpha is very, very large compared to that of beta and gamma. Gamma has no mass at all. It has a 0 mass. Then what about the speed? Alpha is very, very slow and can easily be stopped by a paper. Beta is fast compared to alpha. Then it can be stopped by aluminum foil. That's what you can use to stop that. Then for gamma, it has the speed of light. You can't use a tiny sheet of paper to stop. You can use aluminum to stop it. For you to stop gamma emission, you must use a lead to stop gamma emission. But is it true that gamma is the fastest? No. X-ray is even faster than gamma. It has, the penetrating power of X-ray is faster. The neutron is. We have other emission, but these are the 3 major ones. We have the alpha, we have the beta, and we have the what? The gamma. Please take note. This symbol is for alpha. This very one here is for beta, which can be plus or what? Or minus, positron or negatron. While this very one here is for what? For gamma. So we have the names, which is the radioactive decay or the particles. We have the notation. Then here we have their what? Their symbols. But before we go into this, I want to draw something here. Let's say here is helium. Here is 4. Then here is 2. This 4 here is talking about the nucleus. I don't want to be using mass number again. Why this 2 here is talking about the what? The proton. I don't want to be using atomic number again, since we are dealing with radioactivity. So if you have something like this is alpha, we have 4, we have 2, then this is symbol, this is symbol for alpha. So it's either you write helium or you write something like this, 4 and 2. So for alpha, we have the neutron will be decreased. We have to decrease the neutron by 4. We also have to decrease the proton by 2. So the neutron we have to be reduced, while the proton as well we have to what? To reduce. Then for beta, there is no deflection on the, which is you don't have any problem with the neutron. You only have a problem with the what? With the proton. So you have to reduce the proton by what? By 1. Then for gamma, it shows no deflection. So the nucleus will not be reduced. The proton will not as well be what? Be reduced. So if you look at the neutron here and then the beta emission, it is actually inverse. Okay, the neutron here, the nucleus will reduce, but for beta, the proton, that's exactly what is going to reduce. So for this very one here, you are reducing just the atomic number, but here you are reducing the mass number. So please take note of that, just in case, so that you don't get confused. Then for the proton here, you are reducing both sides, like the alpha particle. But here, hydrogen, sorry, one proton will be reduced, then one neutron will as well be what? Be reduced. These are their symbols. Therefore, a positron, like what I said, positron and negatron, they are both beta emission. So if it is positive, if the neutron decreases, if you decrease, which is if you reduce the proton rather, it is a negatron. But if you increases the proton, then it's a what? A positron. Maybe in we are going to do a little calculation on that, so that you know when it's actually increasing and when it's also what? Reducing. That's for beta, negatron, and positron. So please take note of that. These are some of the examples that are involved in radioactivity. Like what I said before, one of the reasons for radioactivity, which is for the spontaneous disintegration of the nucleus of an element, is for it to attain stability. That is to say, most of what we have here is not stable. And like what I said in my other video, for you to detect that this particular nucleus is stable, the neutron to proton must be, which is the neutron must be equal to the proton, or the neutron divided by the proton must be equal to 1, or the neutron minus proton must be equal to what? 0. So for you to be stable, those criteria must be met. If not, you are not stable. So, and if you are stable, that is to say you are not spontaneous. But if you are not stable, which is if you are radioactive, that is to say you are spontaneous. So please take note of that. And now another thing I want to add again, if you have something like this, it is very, very easy. What you will do is that, let's say here is A, here is B, and here is C. So if you have something like this, they are trying to tell us that uranium is a parent nucleus. It's going to disintegrate to form a daughter nucleus or nuclide. This is a nuclide, parent nuclide, disintegrate to give us a daughter nuclide, granddaughter nuclide, great granddaughter nuclide. That's how it's going to continue till it attains stability. So for now, this is the parent nuclide and this is the daughter nuclide. So if you have something like this, what you easily do, we have A here is equals to B plus C. So we have a value for A, we have a value for B already, but we don't have a value for C. So what you are going to do, let's make C the formula. C equals to A minus B. What is the value of the A? A is 238. What about the value of B? B is 234. Then if you subtract it and then you are going to see our answer here will be what? Will be 4. Then let's go to the bottom part. It's still the same thing you are going to do. Very, very easy. 92 minus 90. So if you subtract 90 from 92, and then you are going to have what? 2. So the question is, what has 2 nucleus and 2 proton? The answer is what? Is helium. That's an alpha particle plus energy that will be what? That will be emitted. As simple as that. Then if you try this very well now, 131, 131 minus 131 give us 0. 53 minus 54. 53 minus 54, that will be a minus 1. So if you have minus 1 here, this is a beta particle. And this beta particle we have here is what we call a negatron. This is a negatron. Please, at the end of the whole thing, energy is usually what? Evolve. Then let's try this out. 8 minus 8, we have 0. Then 5 minus 4, we have what? Plus 1. Then electron again. So if you have something like this, this is what we call a positron. It's also a beta particle, but this beta particle is what? Positron. Most cases, a question might come like this. They will tell you option A, beta particle. Option B, negatron. Option C, positron. The correct answer to this very question is what? Is positron. We know that it's beta particle, but beta particle is more of the canopy. For example, someone is asking you that what's your department? You are saying data science university. We know data science university, but where in data science university? So she be more specific. The answer is what? It's positron. And another thing again, positron might not be there. If positron is not there, there is another English that you see. It's called electron what? Capture. So is that you call it positron or you call it electron what? Capture. Then let's try this out. 13 minus 12, the answer is 1. 4, 4, the answer would be what? 0. So if you have something like this, whereby you have 1, 0, it's usually be a what? A neutron. So please take note of what I'm doing here now. It usually be a neutron. Assuming is at the bottom, which is the atomic number or the proton number, that is when it should be a positron or a negatron. But as far as it's talking about the nucleus, it will be a what? A neutron. And if you see something like this, please remember, energy is usually emitted at the end of the whole process. Then for the last one, here is 12, here is 12, here is 6, here is 6. Then please take note, it has no deflection. That is for what? For gamma ray. And sometimes you might see something like this: option A gamma, option A alpha, option B beta, option C neutron, option D. You will now see something like Oga. The answer is what? Oga radiation. So please take note of all what you are seeing here. So one of the reasons for disintegration is because you are going to break. It's just for it to attain stability. So if a question should come in that format, please take note. The major reason for disintegration, for spontaneous breaking down of the nucleus of an element, is for that nucleus or that nuclide to attain what? Stability. So let's take a look at this last example. Now what happened is that uranium, uranium-23892, is a parent nuclide. It's going to disintegrate to give us a daughter nuclide. This one disintegrated again, it gave us a granddaughter nuclide, a great granddaughter nuclide, a great great granddaughter, a great 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 until it attains stability. So for you to say there is no more disintegration again, that's to say the nuclide is what? Is stable. That is to say the neutron is equal to proton, neutron minus proton is equal to 0, neutron divided by proton is equal to 1. So please take note of that. Then now let's look at this. The question should be, what kind of emission is involved from uranium to thorium, from thorium to prolactinum, from prolactinum to uranium again, to thorium again, to radium again, to radium again, to radon, to polonium, and then to astatine. So what kind of disintegration is taking place? That is the question we should be asking ourselves. So how do we know if here is alpha, if here is beta, if here is gamma, if here is alpha, if here is beta or gamma? So let's get started. Let's just take a look at some of these and then let's guess what the answer will look like. If you look at this closely, here is 234, here is 238, here is 234. 238 minus 234, you are going to have 4. This minus this, you are going to have 2. That is alpha. So what is going to, the kind of emission that will take place here is alpha emission. Then let's look at this. 234 from thorium to protantalum. 234, 234, 91. So here will be 0. Then at the bottom, we have minus 1. So here will be a beta, that's a negatron. Then let's look at this. From protantalum to uranium again. So you are going to have 234, 234, that will be 0. 91, 92. 91 minus 92, you have minus 1. That's a beta, which is a negatron again. Then from this to this, realize that here is 90, here is 2. 92 minus 90, we have 2. This minus this, at the end of the thing, we are going to have 4. So this will be an alpha again. Then from this to this, which is from thorium to radium, we are going to have something like, here will give us 2. Then here, 230 minus 286, we are going to have 4. That's another alpha. Then from radium to radon, we are going to have 286 minus 222. That's already 4. 82 minus 86, that is 2 already. That's another alpha. Then from radium to polonium, let's share 222, 218, that's also 4. Then here is what? Is 2 alpha. So that is to say, from uranium to thorium, we are going to emit, the particle that will be emitted is alpha particle. Then from thorium to protantalum, we are going to emit a a beta negatron. From protantalum to uranium again, you are going to emit a negatron. From uranium to thorium, you have alpha particle that will be emitted. From thorium to radium, you have alpha particle that will be emitted. From radium to radon, we have alpha particle that will be emitted. From radon to polonium, alpha particle will also be emitted. Then from polonium to astatine, what particle will be emitted? Option A is alpha. Option B is beta. Option C is gamma. Option E is beta positron. Option D. Option E is beta what? Negatron. So please, if you feel your answer is alpha, is beta, is gamma, is beta positron, is beta negatron, feel free to drop it in the comment section. Thanks for watching. See you in the next episode. Please don't forget to share this video to your loved ones, share to your Department group chat, tell them to subscribe to Guido Academy. Please don't forget to smash the subscription button. If you find anything confusing at all in this particular video, drop it in the comment section. I will definitely attend to that. For now, goodbye.